All right, we're just going to look at a variety of different curves here. So looking at this first one here, we've got y equals -1 on x plus 1. So if we look at that, we've got a couple of interesting things here. We have the -1, which means that that will just flip it to the other side. And we have the x minus 1, which means that if you look at that, that will be that there would be a shift to the right horizontally. So it'll be a horizontal shift to the right. Whereas this one here, that one will be flipped. So that'll be flipped to the other side. So if you go horizontal shift to the right, that will be there. And if you draw that in, normally it would go there and there. But because we have the negative in front, that means that this curve will actually flip to the other side. So it'll go here and here because of the negative. Okay, so the domain here would be, we're going to go from all real x except x equals 1. So it's -infinity to 1. And then 1 up to infinity. And the range will be from -infinity up to the 0, because if you look at this, you can see that it can't equal 0. I'm just going to go highlighter. So you see there, you can't have x equals 0, and the other one too, you can't have. It's y equals 1, so you can't have y equals 1. Sorry, x equals 1. Take that back. You can't have x equals 1, and you can't have y equals 0. So that's going to go then, if you look at that, it's going to go from 0 to infinity. That's going to be the range. Okay, so let's just look at the next one. So that's going to be, you look at that, that's a -1, so that's going to be left. And that one's going to be up 3. So it's going to be up 3, and it's going to be to the left 1. So it's going to go here and here. Okay, and if you look at the domain and the range here, so the domain would be all of the x's, except we can't have x is -1. And that's also, see, when it's on the denominator, when x plus 1 is 0, that would mean x is -1. So it's going -infinity to -1, and then it's going -1 to infinity. And the range, so when you're looking at the range, that's going to be -infinity up to 3, and then 3 up to infinity, because if you look at that, 3 is what it can't equal. Okay. All right, looking at the next one, so we start off, we go, the y would be 4, because it's going to go up 4. Like if you did it this way around, you see it goes up 4. And then it's going to go to the right 2. So if you go right 2, up 4, okay, to the right 2. And because it has a negative in front, that's going to flip it. So that means when you actually draw it, it's going to be on this side and on this side, because it has the negative. Okay, now looking at the next one, I just want to talk about these numbers on top. So the numbers on top affect what you call the dilation. Okay, so the dilation is whether it's pushed in or it's pushed out. Now, if you look at this here, when you've got 3 over x, just got to change that. So you've got the 3 on the x compared to, say, the 2 on the x. I want you to think about that. Like if you put in different values of x, what effect would that have? Now, when you're looking at that, y equals 3 over x, if you put in x equals, say, 1, then you're going to get 3 over 1, so which is 3. So one definite point that goes through, if you put in x equals 1, it's definitely going to go through 3. And it's just your normal basic hyperbola like that. okay? And if you put in, say, x equals minus 1, then they're going to get 3 on minus 1, which is minus 3. So it's definitely going to go through minus 3. So when it's at minus 1, it's definitely going to go through minus 3, and it's going to look like that. So a point that goes through is 1, 3, and minus 1, minus 3. Okay, that's all good. But what happens when it was 2? So when y equals 2 on x, what would happen there? If you had 2 on x and you put in x equals 1, you're going to get 2 on 1, which is 2. So that means it's going to go through 1, 2. So instead of going through 1, 3, it's going to go through 1, 2. So it's going to be a bit lower like this. So it's going to come down here. And the same as if you put in x equals minus 1, you're going to get 2 on minus 1, which is minus 2. So that means when you put in minus 1, it's going to be at minus 2, which is there. Okay, so it's going to, if you look at that, when it's 2, can you see that it is closer to the 0 or closer to the axis? And when it was 3, it's further out. So basically what happens here, the bigger that number on top, like say it was 10 on x, that would be 110. So, that would be up there. The bigger the number on top, the further it is out from the axis. So the bigger the number on top, the further it is out from the axis. So if I have 1 on x, like that's closer in to the axis, and see it's going to go through 1, 1. Okay, but in 1 I had y equals 2 on x. That means it's going to go through 1, 2. It's going to come a little bit further out. So it'll look like that. And then if I went, all right, y equals 3 on x, it'll come further out again because it'll go through 1, 3. Okay, so the bigger the number, the further it is out from the axis. So the bigger the number, the further from the axis. Okay. All right, so what I'd like us to do is just quickly look at these, and we'll just quickly sketch them. So, that's up 1, and this one's to the left minus 1. So that's where your new asymptotes are, and that'll affect your domain and range. And then just the last one here. So this one, I just want you to see that if it's in this form, x times y equals minus 4, if you just divide both sides by x, then you can see you're just going to have your basic form of your hyperbola. You're just going to have y as minus 4 over x, which is just your negative hyperbola. This hasn't shifted anywhere, and it's just on that side.